3-axis milling. In this video, we will introduce how to use the 3-axis milling operation to create a toolpath, including how to create a tool library, define the reference operation, define limiting boundary, and so on. Now let's begin. Create a new CAM plan and name it Tool Library. Then save the file to the desktop or to another file folder. After that, we can define the tools. Right-click on any blank area and choose Tool Manager in the minibar. Input the tool name D20R0.8 and change the tool radius and diameter. Then set the tool number D register, H register to 1. Then insert a holder and define the parameter as 50, 50, and 40. Then set the speed and feed rates for the finish and rough cutting. You can define the value as you wish. Then click Save All. Find the file folder we just set and choose Tool Library. Then click it and close the Tool Manager. Next, we can define another tool. Also, right-click in the blank area and choose Tool Manager in the minibar. Input the tool name as D6R3 and set the flute length to 20, tool length 40, radius 3, and diameter 6. Then set the tool number D register, H register to 2. Set the speed and feed rates for the finish and rough cutting. Then click Save All and close the Tool Manager. Next, we will define the third tool, using the same method to define it. Right-click on a blank area and select the Tool Manager in the minibar. Input the tool name as D8R4 and set the flute length to 20, tool length 40, radius 4, and tool diameter 8. Set the tool number D register, H register to 3. Then choose Speed and Feed Rate and set the speed and feed rate for the finish and rough cutting. After that, click Save All and select Tool Library. Then click OK and close the Tool Manager. After we finish defining the tool, click Save and close the file. Now, open the file Mill Bottle and relocate the geometry. Click Move under the Shape ribbon. In the options, select from Point to Point. Select these 2 points and click OK. Then, rotate the shape. Also, select the Move command. Then in the options, choose Rotate. Direction set it to Z-axis and rotate the angle by 270 degrees. Then click OK. Next, we should create a CAM plan. Click CAM plan in the Document Aware toolbar. Keep the template as default and click OK. First, we need to create a stock for machining. Click the Stock command. Then in height, set the positive direction material to 2. Then click OK and choose Yes to hide the stock. Then we can create the 3-axis milling operation. First, select Top Face Cut to create the first operation. Select the part and stock and click OK. Then, in the Tool Manager, click Load All. In the Tool Library, select D20R0.8 and click OK. Click OK again to close the Tool Manager. Then click Yes and calculate the toolpath. Here now we will get the Top Face Cut toolpath. Next, we will create a rough milling operation. In the 3-axis milling ribbon, select Offset 2D operation. Set part as the feature and click OK. In the tool list, select D20R0.8 as the cutting tool. Then click No and don't calculate the toolpath. Now we will define the parameter. Set the surface thickness to 0.5, Z surface thickness 0.3, and step down 1. Select Path Setting, set the XY corner to 1. Select Link and Lead, set the short link limit to 5. Lead in ramp angle to 3, and lead in height to 1.2. Then calculate the toolpath. Double-click on the two operation icons and hide the toolpath. Then we should create a rest rough milling operation. Right-click on Offset 2D1 and choose Duplicate. Right-click on Tool, select Manage. In the Tool Manager, select Load All, and in the Tool Library, choose D6R3 as the cutting tool. Close the Tool Manager. In the pop-up window, click Yes. Now double-click on the Ref Op and select Offset 2D1 and click OK. Next, double-click on the parameter and set the step down to 0.5. In Path Setting, select Part as the Path Pattern Guide with the XY corner as 0.3. In Link and Lead, set the short link limit to 10, lead and ramp height to 0.6, then calculate the toolpath. Also here, use the Path Editor to edit the toolpath. Right-click on the Offset 2D1 and choose Edit Toolpath and choose Trim. Then select 4 points and middle-click to trim the toolpath. Click OK. Here we will get the final toolpath. Double-click on the icon and hide the toolpath. Next, we will create the finished toolpath. Click Z-Level under 3-axis milling. Select Part and double-click on Part and click Create. Now select Profile and click OK. Chain select the bottle outline and click OK. Make sure the type is Contain, then click OK. Then, in the tool list, click Manage and in the Tool Manager, select Load All. In the Tool Library, select D8R4. Click OK and close the Tool Manager. In the pop-up window, click No. Don't calculate the toolpath. Next, we should define the cutting parameter. In limiting, set the top boundary to -3. And in the fillets, set the angle range from 30 to 90 degrees. Then click Calculate, which will give us the Z-level toolpath. Next, we will create another finished cutting lace. Select the part and profile as the feature, then click OK. In the tool list, select D8R4, then click No. In limiting, set the top boundary to -3. And in the fillets, set the angle range from 0 to 36 degrees. Then click Calculate. Now we will get the lace tool path. Double-click on the Z-level and lace operation and hide them. Next, we will use Offset 3D to create the finished toolpath. Select Part and Profile as the feature and click OK. In the tool list, select D8R4 and click No in the pop-up window. In limiting, set the top boundary to -3. And in the Link and Lead, change the short link type to On Surface. Then click Calculate. This will give us the finished toolpath. Double-click on the icon and hide the toolpath. Now right-click on the operation and select Solid Verify. Click Run Simulation. Thus we can see the whole cutting process. After that, we can check the rest material. Click Options at the bottom and select Analysis. Click Visual. We can then see result. Double-click on the machine and input 3-axis milling as the machine name. And in Post Configure, select FANUC Basic. Click OK and finish the machine definition. Now we will output the NC code. Choose Top Face Cut 1 and Offset 2D1, then right-click, select Create Output for All. Right-click on P0001 and choose Setting. Click NC Code at the bottom, then we will get the NC code. This has been a general introduction to 3-axis milling. Thank you.